In a recent paper, researchers found compelling evidence against the dark matter hypothesis. But if it is true, it speaks to something even more important. What exactly? Let's find out. The paper deals with the rotation curves of isolated galaxies. Let me remind you that the rotation curve is the dependence of the speed of movement of stars on the distance from the center of the galaxy. And isolated galaxies are those located at a large distance from other galaxies or clusters of galaxies. In other words, galaxies that are not gravitationally bound to other galaxies or clusters. Such galaxies, in addition to the visible star gas disk, have an extended gas disk beyond the visible part of the galaxy. And it is believed that the size of this gas disk is several times greater than the size of the visible part of the galaxy. At least, using the signal from this gas, it is possible to measure the rotation curve at a distance of several galactic radii, and all measurements show that the rotation curves remain flat even at such large distances. Further, the signal becomes too weak. And if you are interested in the topic, you have probably already seen rotation curves that do not slope down. This is where the assumption comes from that the dark matter halo is several times larger than the size of the galaxies. It remained a mystery at what distance they slope down. At some distance they must have a downward slope, since the dark matter halo must have finite dimensions. If it is impossible to measure the rotation curve directly, then another way can be used. The researchers in this work used the weak lensing effect to measure the gravitational potential, and from the gravitational potential, determine the assumed orbital velocity and, accordingly, the rotation curve. You probably know the essence of this effect. This is the effect of light beam deflection by gravitating objects. According to the general theory of relativity, curved space deflects light beams, and the angle of deflection depends on the gravitational potential. And each galaxy is essentially a gravitational lens. And in this work, the object of study was precisely these isolated galaxies. By analyzing the deflection of beams passing near these galaxies, the researchers received information about the gravitational potential around these galaxies. And the result was very unexpected. It turned out that the rotation curves remain unchanged at a huge distance from these galaxies, dozens of times greater than their visible sizes. And at the same time, there are not even hints to find the region of decline of these rotation curves. But what does all this mean in terms of the dark matter hypothesis? Such extended flat rotation curves mean the presence of dark matter halos of unimaginable size, since the edges of these halos have not been detected by researchers. And therefore, it is not even possible to estimate the full size and mass of this dark matter. But we must understand that their mass should grow proportionally to about the third power of their size, relative to halos of smaller sizes. And if we imagine that each isolated galaxy is surrounded by such a halo of dark matter, then it turns out that in reality, there is much more dark matter in the universe than previously thought. And this, in turn, casts a shadow of doubt on the estimates of dark matter based on the CMB, which can further undermine modern cosmology and the Big Bang theory. In addition, many unanswered questions arise. For example, in such a halo there should be a huge number of subhalos, in which many other galaxies should have formed. But for some reason we see only one galaxy instead of this multitude. And the question of why this dark matter is distributed in such a way that the supposed rotation curve in this halo is flat generally baffles any theorist of dark matter. Because if within the visible part of the galaxy, a flat rotation curve is tried to be explained by a conspiracy of dark and visible matter, then far beyond the visible part, the influence of visible matter is negligible and dark matter rules the roost there, which for some reason forms a flat rotation curve. At the same time, there is no theoretical profile of the distribution of dark matter that would give a flat rotation curve. By the way, the above-mentioned conspiracy of dark and visible matter, which is also called the fine-tuning problem, has still no explanation. In other words, there is no theoretical explanation even for the flat rotation curve in the visible part of the galaxy. That is, there is no explanation why dark and visible matter are distributed in such a way that their joint gravity gives a flat rotation curve. But if you search for information on this issue, you may come across another effect called the bulge halo conspiracy. It is also associated with the distribution of dark and visible matter. And in a recent paper, researchers allegedly refuted this conspiracy. But in fact, they only once again confirmed that this problem is not solvable within the framework of the prevailing theory. The essence of the problem is as follows. It turned out that in elliptical galaxies and in part of lenticular galaxies, matter is distributed approximately inversely square to the distance. And it is assumed that dark and visible matter somehow conspire to form exactly this distribution. But if you've seen video number 9, you may remember that this distribution is due to the fact that elliptical galaxies have an inverse square alpha function in all directions. In the same video, using disk galaxies as an example, the basic physical principle is described that explains why matter is arranged according to this alpha function. But within the framework of the prevailing theoretical paradigm, this is still an unsolved mystery. We'll talk about this in more detail in another video. Now let's return to the topic of this video. Considering all the absurdity that the result of this work generates, as well as other problems of the dark matter hypothesis, there are more and more doubts about the correctness of the dark matter hypothesis. But maybe the problem is different? Maybe there is something wrong with the method used in the study? With gravitational lensing. Gravitational lensing is part of the general theory of relativity. And gravitational lensing is one of the pillars of dark matter. If you remember, excessive deflection of light rays is one of the most important arguments in favor of the existence of dark matter. And here there is really a reason to doubt. Since we know quite accurately the mass of the sun and how it deflects light rays. But the mass of other massive objects in the universe is not known to us for sure. And how they should deflect rays is also unknown. We only assume that the theory is correct, and according to the calculations of the theory, we determine the mass of objects by the deflection of rays. But perhaps this part of the theory is really problematic. It is important to understand here that the problem of dark matter arose precisely within the framework of the dominant theoretical paradigm. In particular, the general theory of relativity, the virial theorem, and other theoretical foundations. Therefore, to avoid the problem of dark matter, modified Newtonian dynamics or simply MOND was developed, to which astrophysicists often resort to explain results similar to those obtained in this work. But what is MOND? It is, to some extent, an attempt to correct the calculation formulas in our theories. And if someone still does not know, among astrophysicists there are quite a few who doubt the correctness of the dark matter hypothesis and the correctness of the general theory of relativity. And I say this because I know that there are many people who still believe that real scientists do not doubt the theory of relativity at all. Only pseudoscientists doubt it. After all, this theory has been repeatedly verified experimentally, and experiments are still being conducted to verify it. But try to use the reverse logic. Why is it still being tested if it is perfect? And most people are mistaken, not understanding one simple thing. If experiments confirm the general theory of relativity, this does not mean that these same experiments, with the same results, will not confirm an even more perfect theory. Just as experiments and calculations according to Newton's theory or Kepler's laws coincide with the results of Einstein's theory. An apple falls to the ground equally quickly in both Newton's theory and Einstein's theory. Most planets move the same way in both Kepler's laws and Einstein's theory. To disprove Newton's theory, the problem of Mercury's perihelion was needed, as well as other, less obvious problems. And before these problems were discovered, Newton's theory was also perfectly confirmed by experiments. But these experiments essentially only prove the incorrectness of previous theories. Just like experiments testing the general theory of relativity speak with certainty of only one thing: on the incorrectness or inferiority of Newton's theory. Science works this way. Each time a new theory introduces amendments and clarifications. And each new theory is only a more accurate reflection of reality. A clearer image of the true, small, subtle mechanisms of nature and the subtle threads connecting these mechanisms. With each new theory, we see this picture more clearly and describe the nature of the universe better. But you cannot idealize any theory, no matter how much it is confirmed by experiments. This is the most important thing that any scientist, as well as anyone else interested in science, should know and understand. This is what those who idealize any theory in general do not understand. On the other hand, scientists understand that all forces of nature are interconnected and that they must be united by a general theory, which is commonly called the theory of everything. And perhaps, in order to create it, we will even have to radically change our view of what we call matter, energy, and space. And until we get close to creating a theory of everything, new theories will appear and replace each other. In this understanding, the general theory of relativity is just another stage on the path to a theory of everything. And the general theory of relativity will someday be replaced by a more perfect theory. But now, to realize the need for a new theory, we need to find an unsolvable problem in the existing one. And it seems that such a problem of the general theory of relativity is precisely dark matter. And this study just emphasizes the problematic nature of the dark matter hypothesis, and therefore the problematic nature of the general theory of relativity. By the way, the possibility of the existence of galaxies with infinitely long flat rotation curves, predicted by modified Newtonian dynamics. But MOND is not a theory, as its author himself says. I do not want to belittle or insult its author in any way, but the origin of MOND is similar to the following. Imagine that you are solving a problem in physics or mathematics, but not knowing how to solve it, you resort to trickery. You open the section containing answers to problems and try to come up with a solution based on the answer to your problem. So the founder of MOND, seeing flat rotation curves, simply assumed that on a galactic scale, under conditions of very low acceleration, the gravitational potential decreases not inversely square to the distance, but inversely proportional to the distance. But can we say that the study itself is wrong and that in a few months another study will come out that will refute this study? Maybe so, and this sometimes happens. But there is other evidence for the existence of such huge rotating gas disks around isolated galaxies. And if this is so, then the problem is complicated by the fact that the lambda CDM simulations fail to even produce a semblance of the observed flat galaxies, let alone giant gas disks. And if these gas disks are really so extended, then this may indicate to us that their formation occurs in a completely different way than the hierarchical concept implies. And the assumed rotation speed or gravitational potential at such a large distance may indicate not the presence of invisible matter, but completely different physical principles that form such dependencies. And the discovered massive galaxies in the very early universe are also not explained by dark matter cosmology. But these same early massive galaxies are much better explained by modified Newtonian dynamics. And again MOND. Do you know why? Because the problems of the dark matter hypothesis show us that our theoretical foundations are wrong. And therefore, the eyes of astrophysicists are increasingly directed towards alternatives. And now the most famous alternative is MOND. But MOND is not a full-fledged theory and there is no alternative cosmology based on it. Besides, MOND has enough of its own problems. This is the current situation. Unsolvable problems have emerged, but a strong enough alternative that would solve all the problems is unknown to the scientific world.